Hello, welcome to the first linear algebra clinic. In this clinic, we're going to go over the first problem set, which has to deal with matrix operations. Right. So the first problem we see, we're asked to do a plus b and then 2a minus 3b. So this introduces two matrix operations, specifically matrix addition and scalar multiplication. In order to add two matrices together, they have to be the same dimensions, right? So if we look here, this matrix has 2 rows, 3 columns. This is a 2 by 3 matrix, right? B has 2 rows, 3 columns. That's another 2 by 3. They have the same dimensions, so we can add them together. Right? So to add two matrices together, all we do is add the corresponding entries. Right? In other words, we add the 1, 1 entries, add the 1, 2 entries, add the 1, 3 entries, right? And then add the 2, 1 entries, the 2, 2 entries, and the 2, 3 entries. Right? And so there is a plus b. For scalar multiplication, right? All we do is multiply each entry by the scalar. Let's write it this way instead. All right, so 2a would be 2, negative 4, 6, and then 8, 10, negative 12. Now, technically speaking, there is no such thing as matrix subtraction, right? When you see subtraction, what we're really doing is adding to the negative. So what we're going to do is calculate what negative 3 times b is. And so negative 9, 0, negative 6, 21, negative 3, negative 24. So 2a minus 3b. Two minus 9, negative 4 plus 0, 6 minus 6, 8 plus 21, 10 minus 3, and then negative 12 minus 24. All right, and there would be our 2a minus 3b. Here we're going to solve for x, y, z, and t. Right. First, let's perform the operations. So we're going to do scalar multiplication here on the right. And then we will add. Right. So two matrices are equal if and only if their corresponding entries are equal. Right. So what that means is that we have to have 3x equals x plus 4. We have to have 3y equal to 6 plus x plus y. Have to have 3z equal to -1 plus z plus t. And we have to have 3t equal to 2t plus 3. All right. What we get then is 2x equals 4. X minus 2y is equal to -6. 2z minus t is equal to -1. And t is equal to 3. Right. Well, this first one here, right, we can immediately say x has to be 2. And obviously that last equation gives us that t is equal to 3. So this makes it nice and simple, right? Because now this system will become, since x is equal to 2, we now get 2 minus 2y has to be -6. Now we know that t has to be 3. So 2z minus 3 has to be -1. Right, and this is going to allow us to solve and get x has to be 2. Right, if we subtract, we get -2y is -8, so y itself has to be 4. 2z is equal to 2, so z itself is equal to 1, and then t is equal to 3. And this is taking forever to sync. Excellent. Okay, so apparently that's not going to work. Okay. So matrix multiplication. First, let's look at the dimensions. So A is a 2 by 3, right? B is a 3 by 4. For matrix multiplication, in order for the operation to be defined, right, the number of columns of the first matrix has to equal the number of rows of the second matrix. In other words, what we do is we take a look at the inner numbers, right? 3 and 3, perfect. A times B is defined. The result, A times B, is going to have the number of rows that A has and the number of columns that B has. So our result is going to be a 3 by 4. I'm sorry, 2 by 4 matrix, right? Right. What we're going to do is we have to look entry by entry of A times B, okay? So if we look at the 1, 1 entry, what we want to do is take the first row of A, right, and the first column of B. We do 2 times 2 is 4, plus 3 times 1 is 3, right, and then plus -1 times 4, -4, right? And we do that for each entry. So we move to the 1, 2 entry. Right? So we stick with row 1 of A, but now we look at row 2 of B and we do the same thing. Be -2 plus 9 minus 1. Then 0 minus 15 plus 2. And finally 12 plus 3 minus 2. Row 2, we're going to look at row 2 of A. 8 minus 2 plus 20. -4 minus 6 plus 5, right? 0 plus 10 minus 10, 24 minus 2 plus 10. Equals 3, 6, negative 13, positive 13, 26, negative 5, 0, 32. Okay. Notice that if we try to do b times a, right? It'd be a 3 by 4 times a 2 by 3. Right? 4 and 2 are not equal. B times a is actually undefined. Which points out an important fact that matrix multiplication is not commutative. Right? So we've lost commutativity. You're going to start by looking at the dimensions of each matrix. Right, A is 3 by 3, B is 3 by 3, C is 3 by 3. So A times B is going to be defined. A times C is also going to be defined, and they are both going to be 3 by 3s. So A times B, we're going to get 8 plus 4 plus 0. Then we'll get 12 minus 4 plus 0. 4 minus 4 plus 0, right? So that takes care of row 1. Row 2, we're going to get, what, 4 plus 4 plus 0. 6 minus 2 plus 0. 2 minus 2 plus 0. And then row 3, negative 2 minus 4 minus 1. Negative 3 plus 4 plus 2. Negative 1 plus 4 plus 1. Twelve, 8, 0, 8, 4, 0, what, negative 7, 3, 4. No. This 4 here should have been a 2, right? So then this would be 6. And then according to my notes, these 2 entries are also wrong. -3 plus 4 plus 2. I think my notes are wrong. Oh, I just copied it wrong. Okay, no, that's right. Right. So A times C. 12 plus 0 plus 0. 4 plus 4 plus 0. -12 plus 12 plus 0. Row 2, we're going to get 6 plus 0 plus 0. Then we get what? 2 plus 0, and then -6 plus 0. And then row 3, -3 plus 0 minus 1. -1 minus 4 plus 2. 3 minus 12 plus 1. Eight, 0, 6, 4, 0. -4. -3. And -8. Next, we're asked to find the transpose. Transpose of a matrix is very straightforward and simple. All the transpose does is switch rows to columns and columns to rows. So if we're looking for A transpose, up here we have A being 2 by 3. So A transpose is going to be 3 by 2. Right? The first column of A transpose is going to be the first row of A. Second column would be the second row, so 7, 8, -9. Right, and there's A transpose. B transpose is going to be 3 by 3. All right, column 1 of B transpose is row 1 of B, so 1, 2, 3. Column 2 is row 2, so 2, 4, 5. Right? Column 3 is row 3, so 3, 5, 6. Notice that this is B, right? So B transpose is equal to B. And this type of matrix is special. In fact, this is studied, I believe it's the next problem set. Yeah, I'm pretty sure it is. This is what's known as a symmetric matrix, right? So B is symmetric. So looking at C transpose now. C is 1 by 4. Right, so C transpose will be 4 by 1. Right. C is what's known as a row matrix. So it becomes a column matrix. And finally, if we look at D transpose, well, D is a 3 by 1 column matrix, right? Or a 3 vector. That's going to now become a row matrix with 3 columns. So it'd be 1 by 3. Right, and it's 2, negative 4, 6. Excellent. Right, what we're being asked to do here is verify that if we take B times A first and then take its transpose, it is the same as finding the transpose of A, finding the transpose of B, and then doing A transpose times B transpose for these specific matrices. So this property should have already been proven. I believe it was proven in the lecture video. What we're going to do is just actually now verify it for this specific example. A is a 2 by 3, B is a 2 by 2. So if we do B times A, right, it's 2 rows and 2 columns. I'm sorry, I did that backwards. It's 2 columns and 2 rows, right? So this operation is defined. All right, the result is going to be a 2 by 3. We're going to have 7 plus 8 times 4, then 14 minus 40, and finally 21 plus 48 for row 1, right? And then row 2. Be 0, minus 36, right? And then it'll be 0 plus 45, and then 0 minus 54. Negative 26, 69, giggity. Negative 36, 45, and negative 54. A transpose. Right, first column of A will be 1, 2, 3. It's the first row of A. Second column will be 4, negative 5, 6. And again, that's the second row of A. That is now a 3 by 2. B transpose, the first column be 7, 8. Second column be 0, negative 9. That is still 2 by 2. So A transpose times B transpose is defined, right? 2 columns, 2 rows. The result's going to be a 3 by 2. Right, so first row of A transpose B transpose is going to be 7 plus 32. And then we'll get what? 0 minus 36. Right, second row, we're going to get 14 minus 40. And then 0 plus 45. Finally, third row, we're going to get 21 plus 48, and then 0 minus 54. -39, negative 36, negative 26, 45, then 69 giggity, negative 54. Notice, right? That is the transpose of the B times A matrix we calculated above. Right, that is what we wanted to verify, right? So we're done. So that was problem set number 1. All right, so I'm going to end the first clinic, but that second clinic is obviously going to be problem set number 2. And I think I'm going to do that one on Monday, right? The first assignment is due, I think, the 12th. Let's check. 13th. Right, that's next Tuesday. Really? Oh, that's right. We started on the Wednesday, didn't we? Yes. Yeah, so that'll be due next Tuesday, the 13th. Right. Yeah, so then I'll just do the next clinic, problem set number 2, on Monday. So I will see you then.